So, good morning everyone. So, good morning people online. So, today we are going to discuss heat and thermodynamics, important concepts and questions as well. So, as we all know that we have been covering physics concepts since a week. We started with formulas, first year formulas, second year formulas, next first year questions, second year questions, and today we are about to do heat and thermodynamics. Yesterday we had done mechanics part 1, part 2. So basically this session is meant to cover the expected concepts and questions so that questions are not being repeated, concepts are being repeated. So any such question from any given concept should make you feel better and you should be able to attempt it in a confident way and you should score good. So that is the reason concepts behind the questions are being explained. So make sure that people online and offline as well, open your books, try to note down the problem, solve it, and check whether you are getting it right or not. And please share your doubts if you have any, so that your concepts gets cleared. So we have been running this session since a week, covering entire physics from zero, from scratch. So today we are with heat and thermodynamics. So come on people, online, offline, open your books. Hope you are ready with your books. So let's go to first question. So we are doing both concepts and questions. So make sure that you interact so that this session will not be a monologue. Please share your doubts if you have any. So people watching online, do like the session, share the session so that many get benefited. So hi, hello, good morning everyone. So come on, let's begin this session. Open your books, start doing the problem given. Chalo, try to solve the question. Note down the given data. First, try to physically interpret the question. Note down the data. Try to write the formulas that you know. Try to recall and try to answer the given question. So this question belongs to heat. So the question says that a solid metallic cube having a surface area 24 meters square is uniformly heated. If its temperature is increased by 10 degrees, calculate the increase in volume of the cube. Given alpha, what is alpha? Coefficient of expansivity. So try to find the, see given alpha is given, so he's asking increase in volume. So so what is your answer? Option 2. Okay, any other options? So come on, people watching online, we got one option, that is B. So A. Still. So try to solve the question, man. So at least give an attempt. Okay, it's okay, you may not get the answer. It's okay, fine. But you are here to learn, right? So how do you approach the question? So even we are getting B's and C's here as well. So let us try to first identify the keywords given. Total surface area of a cube, okay, increased by 10 degrees. So calculate the increase in volume. So given, what is given? Alpha is given. So what is being asked? Delta V is being asked. So what is the formula that you have? So gamma V naught into delta T. So this is the direct expression. Substituting gives us the answer. So come on, people, try to substitute, answer me. So what do you get? What is the value of gamma? 3 times alpha. So these are the standard notations that we know from basic heat. These are actually, alpha is the property, thermal property. It differs from material to material. In the similar way, gamma is also a thermal property which depends on alpha and is 3 times of alpha. So what is 15 times 15 into 10 power minus 4? So what is V naught? So total surface area given 6a square is equal to 24. What is A? 2, right? So 2. What is the volume? 8. Right? So what do you get? 15 8s are 120. So something 1.2. So you will be getting this. You need not calculate entirely, like 15 8s 120. So you will be getting something 1.2. So that way you can proceed. So yes, Adhya, Harish, yes, B. So Mr. Giri, you need to check. So yes, Neha, hi, good morning. So come on, open your books. Let's try to solve as many questions as possible so that your JEE Mains Season 2 will be more fruitful, so that similar concepts are being repeated. So let's try to discuss some basic concepts behind it. So let's try to see how exactly we got this. Okay? And what all do we have? Let's try to talk about this as well. So let's see. See, okay. See, the concept is being covered so that any question from similar concept should make you feel better and confident, okay? So how do you define alpha? So how do you define alpha? So the amount of okay. So the change in length, ratio of change in length per Kelvin gives us alpha. So in the similar way, how did we get gamma? We are saying it as 3 alpha, right? So is gamma equal to 3 alpha in every case, or do we have any specific cases? Cube. So this is only valid for cube. Why not others? So what do we get for other things? So if you see in question it is given as cube, right? If it is a case of cylinder, how do you solve? See, same concept. Just he will change the question by giving that cylinder, cuboid, cone. You have n number of figures. Same surface area, same temperature, everything will be same. He will just change the geometric figure. Then how do you approach? See, knowing the question is not sufficient. You need to know the concept, because concepts are being repeated, not questions. So how do you get gamma is equal to 3 alpha? So come on, people online. Yes, good morning, Saket, come on. So the question is, how do we get gamma is equal to 3 alpha? So it is said that it is only valid for cube. So let's try to see how exactly we get gamma is equal to 3 alpha. See, generally, if we try to differentiate volume, we get as delta L by L plus delta V by B plus delta H by H. So here what exactly we are trying to do is that if it is a case of cuboid, you will be having length, breadth, height, 3 different dimensions. So here alpha is same for all sides for a cube. If alpha changes with side, like if body is made up of 3 different materials, like length one material, breadth one material, height one material, you are supposed to take this way, alpha along the length, delta t, plus alpha along the breadth, delta t, plus alpha along the height, delta t. So if it is a case of cuboid, so as the case given is simpler and alpha is same, we took out alpha. So what do we get from this? So from here, we will be getting gamma is equal to 3 alpha. So this is the concept behind gamma is equal to 3 alpha. So we can relate this with bulk modulus as well. So from properties of matter, delta P by P, see the questions are being mixed concepts are being used. Delta P is equal to K, delta V by V. So you can expect a question from fluid mechanics plus, what do you call this? Heat. So you can expect such question as well. So these multi-conceptual questions are expected. So here it is being asked, when do we get TS response sheets? As I guess we need to wait for that. Hope you follow the official website. So if you get any authentic information, we'll definitely update you. So subscribe this Roots Academy, so you get updates. So try to solve this question. So what all do we have? What all properties do we have? See, the other is, okay, surface area, right? So let's try to look at surface area of cube, 6a square. Surface area of cone, total surface area of cone, total surface area of cylinder, total surface area of sphere, try to answer them. Volume of cone. See, you need to know these basic fundamentals so that in exam you don't struggle and questions will be easy. What all do we have? Lateral surface area of cone. So try to answer them. Basic geometrical figures. You need to know their surface areas. You need to know their surface areas. You will be asked in exam, man. Here they asked, right? Total surface of cube, you need to know to solve this question. So in the similar way, so come on. See, this will help you in both maths, physics, chemistry, wherever you go. We're not just confined to physics, these 3 or 4 basic figures. In maths also you need to find surface area. So what is total surface area of cone? So what is volume of cone? Okay, let's start with easy thing. That is volume of sphere, 4 by 3 pi r cube. What is volume of cylinder? Okay, let's start with volume. Pi r square h, volume of cylinder. Volume of cone? pi r square h by 3, volume of cone. So you need to have them on fingertips. Next, total surface area of sphere. See, these are not just confined to physics, okay? So what is total surface area of sphere? 4 pi r square. Volume 4 by 3 pi r cube. Okay, next. Total surface area of cone. Pi r square plus pi r LH. LH or just L? Pi r L gives you just meters, right? L r into L, okay, meter square. So that's how you need to proceed. Lateral surface area is also pi r L, right? So volume of pi r square h. Okay. Here 2 pi r h, sorry, 2 pi r h plus 2 times pi d square by 4 into 2. So 2 pi r square. You can write either, okay? Tops, okay, I'm trying to keep it simple. So that total surface area of sphere 4 pi r square. So this is lateral surface and okay, you are supposed to do from that, okay? So even if you don't know, you can, this is the R, this is the height H. So you can proceed from there. So come on, good morning, come on Rahul, open your book, try to solve the question. We are not just covering questions but also fundamentals behind them. So I guess we covered almost everything from this question, right? So there is nothing new here regarding physics. So option A was wrong, Mr. Venkat. So option A wrong. So let's see next question. So simple questions are being given so that it increases your confidence. Come on people online, comment your answers. Do like the session, share the session so that many get benefited. Not just the concepts and questions are also being covered. Come on, share the session. So answer is required. So the question says that a copper block of mass 5 kg heated to a temperature of 500 degrees and is placed on a large ice block. What is the maximum amount of ice that can melt given specific heat of copper and latent heat of fusion of water? See, okay, you can take it in any way, but the thing asked is maximum amount of ice that can melt. How do you solve? So I will give you a chance to solve if you really want to solve. So come on. See, I guess you have a couple of days left, right? See, basic conservation of energy. Try to apply that law and solve. You will get. So come on, people watching online, comment your answers. So let us try to find the keywords first. Mass 5 kg given, heated to a temperature 500 degrees, placed on an ice block, okay? Maximum amount of ice that can melt. So we have a block 5 kg at 500 degrees centigrade is placed on an ice block. So how do you solve? So heat lost is equal to heat gained. From the conservation of energy. So we don't know the temperature of ice, right? What is the temperature of ice? 0 degrees, okay? Temperature of ice 0 degrees. So from 500, so first let us try to look at the heat gained. M into C. That is nothing but latent heat of fusion, right? 335 is equal to M into M of copper into 0.39 into delta T. What is delta T? What do you take? What did you use? Okay, then see what is the amount of heat? 500 you are supposed to take. See loss in energy is equal to gain in energy for ice. So what do you get? Mass of copper block in grams. Okay, you need to take care of that. So you will get mass of ice melted, right? So how much do you get? So come on, people watching online. So try to simplify and answer me. How much do you get? 5.8. See, I gave all values and you are struggling to substitute, huh? You get 3 kgs, not 1.5. So basically, heat lost is equal to heat gain. What did you do then? Without using 500, how did you get 1.5? Okay. 335. How much? 1.5 you got. 3 you get. Okay, chalo. See what all concepts do we have here. Okay, let's see. So come on, people watching online, comment your answers. So let's try to look at this latent heat of fusion first, okay? Let's try to look at what exactly do we have. So what is the boiling point? Let us try to talk about water. So what is the boiling point for water? 100 degrees, okay. So for a melting point it will be 0 degrees. Do you know about enthalpy, right? Enthalpy, what do you mean by it? See, what exactly happens is that, so let's see how exactly close the door. See, I'm trying to explain the concept behind the boiling and melting point. See, water from minus 10 degrees, let us consider we have water at minus 10 degrees. It will be in the form of solid, that is ice. So minus 10 to 0 degrees. When you give heat, you can see the change in temperature. So from 0 ice to 0 water. So at 0 degrees, water H2O can be in the form of solid or liquid. Okay. In the similar fashion, same thing you can see at 100 degrees as well. It can be as liquid or gas, that is steam. See, from see, I'm trying to explain the concept so that any fundamental question you can expect. So from minus 10 to 0 degrees, when heat is given, you can observe the change in temperature. So at 0 degrees, any heat given will not result in any change in temperature, will result only in change in state, that is from solid to liquid. So once again, from 0 to 100, we can only see change in temperature when heat is given. And again from 100, we have two different phases, that is liquid and steam. So it changes from liquid to steam. So this is called the heat required for 1 kg of water to convert from solid to liquid is known as latent heat of fusion. So here it is vaporization. I guess you call it same names, right? Same names. So this is 335 for water and approximately 2500. So this is the concept behind melting and boiling. So come on, people watching online, we are moving to next question. So this is one thing that we can cover here. So what all do we have? I guess remaining everything is common. So here Q lost. So Q gained by ice. It is not changing its temperature. Only stayed from ice to water. So that is the reason we haven't took product of temperature. In the similar fashion, here it is not changing its state, it is changing only its temperature. So we took MC delta T. So that's how we got it. Let's move on to next question. So come on, people watching online, try to comment your answers and share your doubts so that we can discuss. So come on, people watching on app. So Diksha, Rahul, Akshara, Tejasvi, come on, questions are being given. So try to solve them and comment your answers. Minus 23 degrees centigrade, huh? Check. Huh, 250 Kelvin, okay. Check once again. So when question says that when a gas filled in a closed vessel is heated by raising the temperature by 1 degrees. So change in temperature is 1 degrees. The pressure increases by 0.4%. So what is the initial temperature of gas? If you know the direct relation, you can solve it. So come on, how much do you get? So one option we got as 250. So how about others? So people watching online, comment your answers, share your doubts. So come on, people watching online, comment your answers. So let's try to look at keywords. The gas is filled in a closed vessel and is heated by raising a temperature by 1 degrees. So delta T given. Pressure increases by 0.4%. Pressure increases by 0.4%. The initial temperature of the gas. So how do you solve when all others are constant? So we all know that P is proportional to T. What is this law? Boyle's law? What law? Pressure proportional. Charles' law. This is Charles. So let's try to differentiate. Pressure is equal to some constant. Pressure is equal to some constant into T. Differentiate. dP is equal to dt. So divide 1 and 2. So what is dP by B? 0.004. What is delta T? 1 by T. So you get T as 1000 by 400. 4 is equal to. So the answer is 250. See, delta T, if even it doesn't matter whether you take in degrees or centigrade, so answer will be K in terms of K. So this is the basic fundamental formula, like you can even make out from PV is equal to nRT, like even if you don't remember all this stuff, even from here you can say that P is proportional to T. See, R gets V and R are constants. So they, while differentiating, see what exactly we have done here. We are differentiating dP and dt. K is constant. K is nothing but nR by V. So it doesn't matter whatever you take because they remain constant. So come on, people watching online. So what all concepts do we have behind this? So let's try to look at the gas laws, okay? So we have been revising. So try to write Avogadro kada. So try to write. So people watching online, try to comment. So good morning everyone. So hi Siddharth, hi Abhishek. So we are trying to cover concepts and questions as well. So comment and try to fill the blanks. Okay. Come on, try to fill the blanks. I don't know which Abhishek he is. Some Abhishek came. Come on. So try to fill the blanks. So try to fill the blanks. I guess we have still more laws. Let us first complete this. Dalton's law of partial pressures. Okay. We have, I guess you can cover this in chemistry as well. We are trying to revise the concepts behind each question so that similar concepts are being repeated. As similar concepts are being repeated, we are trying to focus on them. So come on, people watching online, try to comment. So what is Boyle's law? Right? What is Charles' law? What is Gay-Lussac's law? What is Dalton's law of partial pressures? What is Avogadro's law? So what does Avogadro's law states? That at equal pressures, equal volumes, equal temperatures, like they contains equal number of moles. Okay. What is Avogadro number? 10 power plus 23 minus 23. Minus 23. So come on. So hi Priyanka, okay, right. So come on, try to solve the next question. So come on, people watching online, comment your doubts, answers. Like the session, share the session so that many get benefited. Come on, Sujit, Dikshita, Rahul, Mamata, come on. People watching on app as well. So basic fundamental question once again. So try to solve it. So the question says that a flask contains argon and oxygen in the ratio of 3:2 in mass and mixture. The mixture and in mass and mixture is kept at 27 degrees. The ratio of average kinetic energy per molecule respectively will be. See, don't write the question. Write the given data. So similar concepts are being repeated in all competitive exams. Majority of concepts are getting repeated. So this session is basically meant to cover all those concepts that are being repeated so that it won't let you go wrong and it will boost your score at least by 20 to 30%. So you need to know basic fundamentals like, so what does temperature of a gas represent? What do you mean by temperature of a gas? Huh. What does temperature of a gas represent? See, the temperature of a gas is nothing but the average kinetic energy of a substance. So temperature of a gas represents the average kinetic energy. So using that statement, try to answer this question. Calculation. Come on. Using that option B. Okay, let's see. See. So see, listen to my hint carefully. The temperature of a gas represents the average kinetic energy of a substance, temperature of a substance. So using that statement, can you comment anything? See, it is said that the mixture is at 27 degrees, right? Mixture is at 27. So there are two gases, one argon and another is oxygen. So argon, oxygen. So pressure of argon, oxygen, will they be same or not? Pressure of argon and pressure of oxygen, chances of them given total pressure. So they may not be same, right? Volume of argon, volume of oxygen, same. Temperature of argon, temperature of oxygen. Temperature of total is Tt. Will temperature of argon and temperature of oxygen be same or not in a given? Same. See, their mixture is kept at 27 degrees. So my statement was temperature represents the average kinetic energy. So the question is ratio of their average kinetic energy. As the temperatures is same, they are also same. So ratio is 1:1. Because the temperature represents the average kinetic energy of a molecule. Because the total temperature is same. Because average kinetic energy represents the total temperature. Next. Come on, people watching online, try to comment your answers. Do like the session, share the session so that many get benefited. Do comment your doubts as well so that concepts get cleared. So come on, next question. So the question says that geyser heats water flowing at a rate of 2 kg per minute, okay? So the water gets heated from 30 degrees to 70 degrees. The geyser operates on a gas burner. The rate of combustion of fuel will be dash gram per minute. So beware of units, gram per minute, kg per minute. Question may kg per minute was given, and in answer gram per minute is being asked. So find the heat of, so the given heat of combustion is 8 into 10 power 3. The specific heat of water is given. Try to solve basic fundamental question. Comment your answer, people watching online. the same conservation of energy. Try to apply that principle and you can make out. There is nothing much logic involved here. Come on. See, the question says that. So let's try to. Come on, let's try to solve the question. So given mass flow rate is given 2 kg per minute. Okay, from 30 degrees to 70 degrees. Okay, now let us try to look at what is being asked. So the heat required is equal to 2 into mass flow rate, heat required per minute, mass flow rate into specific heat into delta T 40. So how much do you get? Q per minute. So joule per gram. Okay, let us try to take it as 2000, right? 2000 grams, 4.2 joule per gram per degree centigrade. So what is the answer? 84, huh? Okay, 32 into 10 power 5 joules. So in the similar way, what is being asked? What is the combustion required? Same. This should be equal to, let us consider this value as x. X into gram per minute into 8 into 10 power 3. This is joule per gram, gram per minute, joule per minute. I guess even we got here joule per minute. So what is this? 40, right? 8 4 is 32. We get something as 440. I guess it's 400, huh? Four, okay. So 40 gram per minute. That's how you are supposed to solve. Chalo, next question. Come on, people watching online. So come on, people watching online, share your questions, doubt. So come on, solve this. So what does question say? Heat engine operates with a cold reservoir at temperature 324 Kelvin. Minimum temperature of hot reservoir. The heat engine takes 300 joules of heat from hot reservoir and delivers 180 joules to cold reservoir per cycle. So the question is the minimum temperature of hot reservoir. What is the minimum temperature of hot reservoir for given conditions? Concept of heat engine, basic fundamental concept, direct formula you can make out. There is nothing much logic involved. So come on, people watching online, comment your answers. So people, those who watch later, try to watch it at 1.5x or 2x if you really feel it slow. So the questions and concepts being covered are really being repeated. So make sure that you don't miss it because it is slow. So come on. So direct, straight question. See, you get easy questions from heat and thermodynamics, so you cannot miss, you cannot take chance. You can score easily. Come on. So how to solve this? See, heat engine, what is heat engine? Come on, people watching online, comment your answers, okay? Heat engine operates with a cold reservoir at temperature 324 Kelvin. Okay? Let us consider it as TH. The heat engine takes 300 joules heat from the hot reservoir. Okay. And delivers 180 heat to the cold reservoir. Okay. Per cycle is dash. So what is he trying to ask? He's trying to ask TH. What is the efficiency you get? What is the efficiency? Work done by Q in. So what is work done? 120 by 300, which is equal to 1 minus 324 by TH. So you get 540 Kelvin. Come on, people watching online, share the session, like the session so that many get benefited. Okay? So efficiency done. See, what is the formula? 1 minus T2 by T1. Okay? So, let's go for another question. Come on. See, what exactly we do is, this is the given data. So, as you know the formula of efficiency, work done by Q in. So, work done is equal to heat in minus heat out, right? So 300 minus 180, 120 by Q in 300. So what is the other formula for efficiency? 1 minus T2 by T1, okay? So through that we can make out. So what is, so let's try to discuss the concept behind them as well. So come on. So what all do we have? So what is the concept? We have heat engine, their efficiency, refrigerator, heat pump, so what is their COP? I guess people have COP, right? Coefficient of performance. So what is their COPs? Try to write their formulas, okay? So what is Kelvin Planck statement? What is Clausius statement? So people watching online, try to comment. So we are trying to revise the concept behind the second law of thermodynamics. So try to ఏంటిది and try to write all those things that you can recall from second law of thermodynamics. Try to define entropy as well. So try to recall, put it on paper, what all you know. Come on. So people watching online, try to fill the blanks, comment in the chat box. So what is COP? Coefficient of performance, right? So how do you write efficiency of heat engine? Q1 minus Q2 by Q1, right? So is equal to 1 minus Q2 by Q1 is equal to 1 minus T2 by T1 for Carnot. Okay? This is the case of efficiency. So what is this refrigerator COP? What does COP mean? Coefficient of performance, right? So how do you define COP? A ratio of, what does QOP stand for? What does coefficient of performance gives us? See, direct question, they will give you data and ask COP. So what do you do? So COP. COP is nothing but ratio of, you can write it as desired effect by work done. Same. So what is the desired effect in case of refrigerator? Heat removal from low temperature. Nothing but Q2. If we follow the standard notations, that is Q2, okay? By what is work done? Q1 minus Q2. So what is desired effect for heat pump? See, you can take this as is this a refrigerator or heat pump? Heat pump, okay. Or is it a refrigerator or heat pump? Heat pump. How can you say? How are you saying? Ah, in case of refrigerator, what will it be? What changes will make it a refrigerator? See, you can call it as a refrigerator or heat pump. Doesn't matter. It only depends on what is the purpose. If your purpose is to remove Q2, it is refrigerator. If your purpose is to add Q1, it is heat pump. So you can call same device as both refrigerator or heat pump. So COP of refrigerator, Q2 by Q1 minus Q2. COP of heat pump, Q1 by Q1 minus Q2. So the relation between COP of refrigerator and COP of heat pump. So COP of refrigerator given, how do you find COP of heat pump? So people watching online, what is the relation between COP of heat pump and COP of refrigerator? This is straightforward question you can expect in any exam, one line question. How can we bring one from the other? See, you even I have given you relationships as well. See, what do you try to add this, okay? What do you get? Add 1 and solve. What do you get? LCM చేసి ఏమొస్తుంది? Okay, what do you get at the end is that COP of heat pump is equal to COP of refrigerator plus 1. COP of refrigerator plus 1. That's what you get. Relation between COP of C. You go try to take LCM Q2 by Q2 plus Q1 minus Q2 by Q1 minus Q2. Q1 by Q1 minus Q2. Q1 by Q1 minus Q2. What do you get? COP of heat pump. So COP of heat pump is equal to 1 plus COP of refrigerator. This is a basic fundamental thing that you know. Come on, people watching online, comment your answers. Come on. Next. Try to solve this. So people watching online, comment your answers, share your doubts so that many get benefited. So do like, share the session. Come on. Hi everyone. Good morning. Come on, Akshara, open your book, try to solve the question given, share your answer. So share your answer, share the session so that many get benefited. So the question says that a thermally insulated vessel, what does thermally insulated vessel says? So the question says that a thermally insulated vessel contains an ideal gas of molecular mass m in the ratio of specific heats is 1.4. Vessel is moving with a speed v and suddenly brought to rest. Assuming no heat is lost to the surrounding and vessel temperature of the gas increases by dash. So given molecular mass, ratio of specific heats, so try to find, what will you find? Temperature of the vessel. How do you solve this? So people watching online. So Mr. Pawan is saying C. Let's see. So what are the keywords? Insulated vessel. What does this mean? Delta Q is equal to 0. Okay. An ideal gas of molecular mass M. Okay. Ratio of specific heats gamma 1.4. Diatomic we can make out from this. See, it is moving with the speed v and brought to rest. Assuming no heat is lost to the surroundings, what is the vessel temperature of the gas increases by dash? So when body suddenly stops at rest, what does the heat convert into? What is the kinetic energy convert into? It converts into heat, right? So the kinetic energy completely converts into thermal energy. So what is kinetic energy? Half mv square. So how do you write thermal energy? How do you write thermal energy as? Huh? How do you write? What is F? Degrees of freedom. Okay. So NF by 2 R delta T. Direct relation you can make out. So what is your answer? What is N here? What is N? How much do you get? So what is F? Degrees of freedom. What is F? Okay, chalo. So is it monatomic or diatomic? Monatomic. Ideal gas can be any atomic. So is it monatomic or diatomic or triatomic or? Which atomic it is? Monatomic, diatomic, triatomic? Basic question. Without that you cannot solve many problems. Without knowing that. What is gamma for monatomic? Gamma value for monatomic. 1. Diatomic? Triatomic? What is this 1.4? For which atomic? What is monatomic? So this is What is gamma for monatomic? (1.67). Diatomic. Triatomic. 1.33. You have them in chemistry. In chemistry, you will use them left, right, top, bottom, like anything. So you need to be aware of it. So what is degree of freedom for diatomic gas? 1.4 is gamma. I am asking degree of freedom. Are they same, different? So people watching online, try to comment your answers. So do like this session, share this session so that many get benefited. So what is the degree of freedom for monatomic gas? For monatomic gas, degree of freedom is 3. For diatomic gas, degree of freedom is 5. For triatomic gas, degree of freedom is 7 or 6? Sure? 6. So here it is diatomic. So we are using 5. Come on. So basic fundamental question. People watching online. Huh? Next question. Insufficient data to draw any kind. B. B. Okay. Okay. Chalo. How and why? Huh? Okay, chalo. So how? Okay, A. Okay. So how? Try to comment your. So why A, why B, why C? Huh? So why A, why B, why C? Okay. See, in both cases, temperature is growing, right? Huh? That's okay. See, I'm not getting your logic actually. So people watching online. Why? Sorry? What is more for P2? Okay. So see, for a given volume, P2 is greater than P1. Is that what you are saying? How can you say that? For a given temperature. On what basis are you saying? So basic fundamental question once again. Try to solve it. So next. So question given, according to kinetic theory of gases, 4 statements are given. So which among them is correct? The motion of gas molecules freezes at 0 degrees. The mean free path of molecules decrease if the density of molecules is increased, option B. Option C, the mean free path of gas molecules increases with temperature is increased by keeping pressure constant. So option D, average kinetic energy per molecule per degree of freedom is 3/2 kBT. So choose the appropriate answer. So C and D are correct. Okay, let's check. How about why A is wrong? Does not depend on temperature. See, you are listening. Even if you are attentive in this today's class, you will not pass that statement. Because just now we said that average kinetic energy is directly proportional to temperature in previous question. Then how can you comment that motion of a gas freezes at 0 degree? What does average temperature? Half mv square. V stands for velocity. Velocity is proportional to temperature. Then how can you say that independent of temperature? That shows how attentive you are. See, not just the answers, but also the concept behind them is being covered. So, how about statement 1? Is it true or false? Statement 1, I am asking about statement 1. Huh? So, the motion of gas, is it true or false? If true, why? False. Okay, say confidently, even it might be wrong. You know. Come on. So, false. Not 0 degrees. It freezes at 0 Kelvin. So first statement is false. So the motion of gas molecules freezes at 0 Kelvin, not 0 degrees. It is depends on temperature, obviously, but freezes at 0 Kelvin. So second, the mean minus 273 degrees. Exactly. So what is second statement? A mean free path of gas molecules decreases if the density of molecule is increased. See what happens if density decreases. Volume increases, right? So how is it related to mean free path? If volume increases, will mean free path increase or decrease? Increases, okay. Let's see option C. The mean free path of gas molecules increases if temperature is increased, keeping pressure constant. How can you say? See, pressure is constant. We are trying to increase temperature. So what does mean free path stand for in the first case? What does mean free path? What do you mean by mean free path? Molecule. Individual distance traveled by molecule before colliding or in collisions. So C is saying that pressure is kept constant and you are increasing temperature. Will mean free path increase, decrease, remain constant? Okay, how about option D? The average kinetic energy per molecule per degree of freedom is 3 by 2 kBT. See, this is not 3 by 2 kBT, it is half kBT. So option D wrong, option A wrong. So B and C. See, hope you got why this is correct. Because volume is increasing. If you want to decrease density, volume need to be increased. So that increases mean free path. So in option C, if temperature is increased, by keeping pressure constant, volume should increase, which increases the mean free path. That is not 3 by 2 kBT, that is half kBT. Huh. Okay, I guess it is 3 by 2 kBT. So that's how we need to proceed next. So, come on. Chalo. Next question. Try to note down the data. So the question says that, okay, start chesam. So come on. So what percentage of kinetic energy of a moving particle is transferred to a stationary particle when it strikes the stationary particle of 5 times mass, assuming the collision to be head-on? So I guess this is from collisions, not from thermodynamics. Okay, let it be. It's part of physics, right? So solve. This question from collisions, not thermodynamics or heat. So let it be. It belongs to physics, right? So come on. చేయండి మేడం. Keep it in silent mode and people watching online, comment your answers, share. Come on. Come on, people watching online, comment your answers. One option is A. So, check. Come on. So, how to solve this? How to solve this? Come on. See, note down the data. See, simple fundamental question, direct straightforward question from elastic collision. Hope we have discussed conditions for elastic collision, right? So try to solve them. Option A is not correct. Check. Come on, people watching online, comment your answers. How do you solve? See how to approach the question. Okay, let us not get for elastic collision E is equal to 1. So using that you will get a relation. First condition. Second condition, momentum is conserved. Third condition, energy is conserved, kinetic energy. So using all these three conditions, try to solve it. What do you get? See, what is the relation between U2 and U1? What do you get? Okay, what is the final relation that you get? See, U2 is velocity of body 1 after collision. Sorry, head on ante straight within the plane of paper. ఇలా సైడ్కి తగిలి బయటికి రాకుండా స్ట్రైట్ లైన్. సో U1 is given. U2 is, what is the value of U2? Initial velocity of second object, 0. So U1 given, U2 0. What is V1? V1, V2. So you need to find relation between U1 and V1. So once you are done with this, so what percent of kinetic energy is lost? So how do you solve? See, let us try to write the key words first. Stationary particle. So U2 is 0, okay. Stationary particle of mass 5 times. M2 is 5 times M, right? So elastic collision. E is equal to 1. So what do you get? So this is what we get from this relation. So if you try to use conservation of momentum, what do you get? Mu1 is equal to mv1 plus 5m v2. So what do you get? So this is the second relation that we get. So from kinetic energy conservation, so these are the three equations that you get. So if you try to equate these two, what do you get? So we need to proceed this way, and you will get and substitute here. You will get relation of V1. And what is the being asked? Huh? Titala unda? Okay. So if you try to solve it, we get something as 55%. Okay. Same basic fundamental using these three relation E, U, right. So come on. So EAMCET sheet and key. So basically we are trying to get authentic information. When we get authentic information, we definitely share with you. So no worries. So stay connected with, let it be. So stay connected with Roots Academy. You get all the updates. So no worries. Yeah, come on, people watching online, comment your answers. So what does the question say? Come on, try to solve the question. So how to solve this? Try to solve that. What does question say? A Carnot engine, temperature of reservoir is 527 degrees and that of sink is 200 Kelvin. The work done by the engine when it transfers heat from reservoir to sink is 12,000 kilojoules. The quantity of heat absorbed by the engine from the reservoir is dash. So how much? So basic concepts of heat engine, direct formula you can make out. So what do you get? Answer. It is all. Okay, you are supposed to convert it into Kelvin and answer the question. So how much do you get? So how to solve? Okay. So what did you get from question? Five by seven. Okay, let's check. See, it is in the power of 10 power. It's some integer. So come on. So how do you solve? See, see what is the keywords? 527, 1, 200, other, 1200, 12,000. See, what do you mean? Temperature of reservoir. 700, 700, 800. 800. Sink 200. Work done by the engine when it transfers heat from reservoir to sink. 12,000. The quantity of heat absorbed by the engine from reservoir. What is this Q1 is being asked? So what is efficiency? Right? This is the efficiency. So what is this? How much will you get? Come on. Come on, come on. So 1 by 4 is equal to 12,000. Work done is equal to, what is work done? 3 by 4. See, 3Q1 is equal to work done. 3 by, what is the efficiency? 3 by 4, right? So work done is equal to 3 by 4 Q1, right? Is equal to work done. What is heat released? Q2 is equal to 1 by 4 Q1, right? Q2. What is being asked? The quantity of heat absorbed. So what is Q1? What is Q2? 12,000. So something you will get. So 10 power 6, right? 48. Something you will get that. I guess it is 16, man. You are. See, what is this efficiency? 800, right? Reservoir 800, sink 200. What is the work done by the engine when the heat transfer? If the work done, see, what are you doing, man? This is work done. This is work done. If the work done by the engine when heat transfers from the reservoir to sink is 12,000 kilojoules, you get right? 16. So come on, people watching online. So see, direct formula, work done given 12,000. Okay? Efficiency, work done is equal to 3 by 4 of Q1. Nothing but work done is equal to efficiency of Q1. Efficiency is equal to 3 by 4 of Q1. So he's asking Q1. How can you say that? The quantity of heat absorbed by the engine from the reservoir. See, 12 into 10 power 6 joules. 16,000 kilojoules. So 16 into 10 power 6. Right? Come on, let's do next question. Come on, people watching online, comment your answers. Do like the session, share the session so that many get benefited. Not just the questions, but also the concepts behind them are also being covered. So what does question say? A sample of an ideal gas is taken through a cyclic process A, B, C, A. As shown in the figure, it absorbs 40 joules of heat during the part AB, no heat during BC, and rejects 60 joules during CA. A work of 50 joules is done on gas during part BC. The internal energy of the gas at A is dash, that is 1560. The work done by the gas during the part CA. So first law of thermodynamics, if you are aware of it, it is just a cakewalk for you. If you are aware of first law of thermodynamics, what is the answer? Huh? So what is the answer that you get? Huh? Okay, come on, make it fast. Note down the data, logic, formula, solve, answer. So people watching online, you can watch it at 2x or 1.5x speed if you really feel it slow. Come on. So what is work done in process AB? Work done in process AB. Work done in AB. What is AB there? Vertical line, right? See, in AB, volume is constant. So what is work done? 0. So work done in AB 0. So the internal energy. Answer in the 30, huh? Okay. Come on. Come on, let's try to solve the question. So what is given? A sample of ideal gas is taken through a cycle of process ABCA. It absorbs 40 joules of heat during AB. So what is QAB? Plus 40 minus 40. Plus 40 minus 40. So QBC. And Q reject. Plus 60 minus 60. So work done on the gas during BC. Plus 50 minus 50. Plus 50 minus 50. The internal energy of the gas at A is given. So how do you solve? What is the work done in CA? Okay, so try to guess whether it is positive or negative. What is work done in CA? Will we get positive or negative? You can guess. Negative. How? Huh? Work done in CA is positive or negative? Negative. How and why? If positive, how and why? See, from the figure you can guess. See, you don't need question. From figure you can guess whether work done during CA is positive or negative. Huh? Positive. Why? See, okay, total work done is negative. That you can make out. CA anti-clock. You cannot say whether it is anti-clock or not. How can you say? Huh? It can be clockwise, right? Even it can be clock. Here it is anti-clock. Only consider CA. It can be clockwise as well. Down, right? It can be anti-clockwise. It can be clockwise as well. So, how can you say? See, from C to A, volume is increasing. So, what is work done? P, V final minus V initial, right? So, V final is greater than V initial. So, work done is positive. So, you can eliminate two options. You don't need concept. See, this is how logically working for guess. Don't blindly guess. Logically guess. Logically eliminate options, okay? So let's try to look at first law of thermodynamics. So come on, people watching online. So what is first law of thermodynamics? What is first law of thermodynamics? So is this for process or cycle? So is this for process or cycle? Cycle. So is this formula valid for cycle or process? Come on. So is this valid for process or cycle? Cycle. So what is it for? So this is thermodynamics first law. So come on. So try to apply. Try to apply. So try to apply this. So what do you get? So try to comment your answers. So yes, Miss Shruti, definitely we are trying to cover the concepts, not just the questions. So definitely this will be helpful for your JEE mains. See, okay. So what is work done? So what is work done in AB? What is work done in A? What is work done in AB? What is work? Such things will not be entertained. Come on. See what is work done in AB? Zero. So how to solve? 30 వచ్చిందా అందరికి? See direct formula application, okay? First law of thermodynamics. Shall I go to next question? Huh? So what do you solve? How do you solve? Come on, come on. So work done. Okay. See, shall I skip or? Huh? Skip, not stop. See, you can directly apply first law of thermodynamics. You can get, okay? How about the yellow dress? Is it okay? Come on. Chala. See, what do you get? So come on, try to solve this question. What does question say? What will be the effect of root mean square velocity of oxygen molecule? The temperature is doubled and oxygen molecule dissociates into atomic oxygen. So how do you solve? This question belongs to kinetic theory of gases. How to how to solve this? See, what will root mean square depend on? What will root mean square depend on? Huh? A. Okay, let's check. So one option we got is A. So come on, people watching online, come on, comment your answers. See, V is proportional to T by M. So using this hint, try to answer. Temperature doubled, oxygen disassociates. So what do you get? So M2 will become M by 2 because it is getting disassociated. So T2 becomes double. So it is D, Miss Shruti. Come on. People watching online, comment your answers. Do like the session, share so that many get benefited. Come on, let's go to next question. See, V is proportional to T1 by T2, M2 by M1. So, doubles 2:1. Okay, this is from electromagnetism. Okay, how do you solve this? Come on. So people watching online, comment your answers. So how to solve it? So come on. So అలసిపోయినా అప్పుడే ఏది So come on. So what does question say? At what temperature of gold ring of diameter 6.23 centimeter be heated so that it can be fitted to a wooden bangle of diameter 6.241. Both the diameters have been measured at room temperature. So what should be the increase in temperature so that the gold ring fits to 6.241? Thermal properties of a material. We had done similar question in today's session only. So come on. So let us try to look at the keywords. So Shruti, option D. Come on. Okay, Shruti, let's check. So let's check. So what is the temperature of gold ring? Diameter be heated so that it can be fitted to a diameter of okay. So try to tell the temperature difference now. See, why are we taking delta T? Because we are considering it as one dimension. We are considering D as a dimension and working on it. Okay? So what do we get? Come on, answer. Answer. Substitute and solve. So what do we get? Delta T? 6.0 Anna. What do we get? Huh? Okay, Adya. So what is the delta T? How much do you get? So this is the formula. Proceed. Direct question. Next. Substitute in that you will get. See, even I have to calculate, right? So come on. Try to solve this. Come on. Easy question, direct question. Does question say that starting with the initial same conditions, an ideal gas expands from volume V1 to V2 in 3 different ways, okay? The one is isothermal, the other is adiabatic, the other is isobaric. So which of the following work dones are more, less? Seriously, Ram. See, how do you solve it? See, let's try to draw the PV graph for it, okay, first. See, what does work done? Area under PV graph, right? So what is work done? What is work done for PV graph? Try to draw the 3 graphs. That is See, how does isobaric graph look like on a PV graph? Huh? Straight line, right? So how does isothermal? So what is adiabatic, B or C? Ah. See, among B and C, which is adiabatic, which is isothermal? Huh? B is adiabatic, C is isothermal. Your exam is just 1 week. You are saying B as adiabatic. Huh? Huh? Isothermal. See, okay, say once again. Is B isothermal? Is B isothermal? So what is A? Isobaric, right? So which among these have more work done? 1, 2, 3. 3 has more work done, right? So 3. Next. Next to 2. Right? So this is how we need to proceed. Area under PV graph, that is D. So come on, do this question. So what do we get? So come on. So last question. Come on. Come on. So come on, people watching online, try to comment your answer. So those who watch later, make sure that you do watch in 1.5 or 2 speed, so that we are taking time. It is getting late. We are a bit. So if you, So how do you solve? See how and why. So how to solve this? You better focus on something that is related to physics, okay? So how do you get? So what do we have? Let us try to look at keywords. So yes, the concepts are also being explained. Come on, let's try to focus. So a vessel contains 16 grams of hydrogen. And 128 grams of oxygen. At standard temperature. So what is standard temperature and pressure? What are the values of STP, standard temperature pressure? 22.4 liters. That is volume. Okay, that is one condition. How about pressure and temperature? See, STP conditions. 22.4 liters, first condition. Okay. Next, temperature. Next, pressure. So try to apply PV is equal to nRT here. So what do we get for N? Number of moles given weight by molecular weight. Given weight by hydrogen 2 plus molecular weight. So how much do you get volume? 273.15 Kelvin. How did you get that? What is the value of P? So we get volume as right. So let's try to end our session here. So find V from that. So as we have been covering physics since a week, from day one we started with formulas of first year, second year, next questions from first year, second year, and we are doing topic wise now. So do like the session, share the session so that many get benefited, and stay connected to Roots Academy by subscribing it. So we will come up with another session the following day. So let's try to end our session today. Thank you all. Thank you for being patient.